Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, we are going to go over Castigliano's second theorem. And basically, this is a continuation of finding deflections in structures. Last time, we looked at the conjugate beam method. And this time, I will start with Castigliano's theorem in the easiest form, which is finding finding deflections in trusses. Why? You know that trusses are the easiest um, structures to analyze because all the members there are two force members. So you don't have moments inside members. So it's just axial loads, either compression or tension. And that's why um, basically it's easy, but then maybe we'll have another session for finding deflections in beams or frames, and you will see it's more involved. So what does Castigliano's second theorem say? It says that if you are looking at a deflection due to a load, notice that loads produce strain, and strain is basically a kind of deflection, right? So you will have rotation and deflection. So, or slope and deflection. So how do we calculate the deflection? So Castigliano says that the load that produces the deflection, if you know it, then all what you have to do to find the deflection is to take the partial derivative of the elastic strain, so of the strain energy with respect to that load. It's as simple as that. You know how to find the strain energy, of course, in axial members. It's 1/2 F square, which is F is the force, L over EA. So when you take the derivative with that, the 2 of the square cancels with the 2 in the 1/2, and you get FL over EA times the partial derivative of the force with respect to that P. Okay, the force is in the members in this case with respect to P. So in this problem, it says determine the vertical deflection of point C if each member has a cross-sectional area of 400 square millimeter and E for the steel here is 200 gigapascal. The first thing that we notice is that we don't have vertical load. So what do we do? If they said calculate the horizontal deflection, where would point C end up? Yeah, I can use the 4 kilonewton right there. But if I'm told vertical deflection, the way we approach it is that we use a fictitious load. So I'm going to call it P. That's the P load. And then we are going to apply Castigliano's theorem after we find the reactions and the forces inside each member. And then we can say, well, alrighty, so I'm going to take the derivative of all the forces with respect to P. And then because P didn't exist, you just used it, right? It's fictitious. You have to set it equal to 0. So we only use it to find the derivative of the forces with respect to P. But once we are done with that, set it equal to 0. So let's start by solving the reactions and the forces. I'm going to redraw it quickly, like so we don't waste time. Here is the truss. I have a force of 4 kilonewton to the right, a force of magnitude P. And I have the distances here from the vertical is 4 meters. And the height is 3 meters. And this is my X, this is my Y. This was a pin, so I have horizontal and vertical forces. At point A, I'm going to call it A sub Y, A sub X. And B is only a roller, so I have B sub Y. Okay, Finding the reactions is so easy. I just have summation of the forces in the x equals 0. I have 4 to the right and a sub x to the right equals 0. So a sub x equals negative 4 kilonewton, meaning equals 4 kilonewton to the left. And of course, we knew that just by looking, but just so we can correct that, we are going to do this to the left. Okay. The sum of the forces in the y, I have PP is exactly in the middle. It's a waste of time. Just split it P over 2 and P over 2, right? It's just this force is split as P over 2 and P over 2. But how about the 4? Again, a quick way to do it. We know that there is a 4 to the right, 4 to the left. That's a clockwise couple. Its magnitude is 4 times the perpendicular distance, which is 12 kilonewton meter. So the two forces of AY and BY that will be added to P over 2 and P over 2. Notice P over 2 and P over 2 don't produce any moment. They cancel each other, right? With the P. So, but the 4 kilonewton, we said times 3 is 12. So there are two forces, one going up and one going, I'm just saving time instead of writing summation of the moment about A or B. And I would say, okay, this couple has a magnitude of 12, right? To counter the 4 times 3 that's going clockwise. So this one is going counterclockwise. Its magnitude is 12. And it's force times distance. The distance is 8. So 8 times the force equals 12. The force is 12 over 8. The force is 1.5 kilonewton. So 1.5 kilonewton and 1.5 kilonewton. These are the forces at the support, or the reactions at the supports. I have 4 kilonewton to the left. So let's delete the A sub x and A sub y and instead write 4 kilonewton. There is no A sub y. We already have that as P over 2 minus 1.5. And also this one would be P over 2 plus 1.5 kilonewton. Okay. Now, the equation says that the delta, they usually use delta. I prefer to use this delta, but if you use it as a triangle, that's fine. Delta at C, well, delta at any point is really FL over EA, right? Times partial F over partial P and then we set P equals 0. So really I need 4 things. They give me the cross-sectional area of 400 square millimeter. The E will be calculated at the end or divided at the end. So really I can say member. I can say the length. Then I will need to find the force. The area is constant, so after that I will say partial F over partial P. And then I'm going to multiply F times L over A times that without the E, okay? It's easier. So we can say FL partial F over partial P over A. For the 3 members, there are only 3 members because otherwise it would be too lengthy. It's not hard, but we don't want to waste your time in going over mechanics, right? Math. You have a calculator, so you can do these quickly. Okay, so let's find now. I have 3 members. The length, the forces that we will calculate, partial F over partial P, and then the total that we will add, and then divide this total by E to find the vertical deflection. Suppose also the problem asks you to find the horizontal deflection at C. You already have a 4, so I'm not going to, first of all, I will take this one out, and I only have the 4. But instead of dealing it with 4, I'm going to call it P. Do you know why? Yes, because if I can keep it 4, how do I take partial F by partial 4? It doesn't make even sense. So I'm going to keep it called P, so I can take the partial derivative, and then at the end, instead of deleting it, I'm going to replace it with 4. This one equals 0, so I'm going to replace it by 0, but this one is 4, so I'm going to replace it by 4. Should be pretty straightforward. So now we have 3 members. I have AB, I have AC, and I have BC. The length of AB is given to me as 8 meters, but since everything is should be using millimeter, I'm going to write it as 8,000. Notice this is a 3, 4, 5 triangle. This is 3, 4, so that's a 5. Don't need to calculate. These are 5,000 millimeter, 5,000 millimeter. Now, let's try to find the forces in the members. So you can see this pin, we learned when we analyzed trusses is that you can write 2 equations in 2 unknowns. We start with some of the forces in the Y to get the force in AC, and then some of the forces in the X to get BC, right? You can start anyway. You can start here and find BC and then AB. It's up to you. Doesn't matter. Okay. So the way we are going to do it is to say joint, so free body diagram of joint A. Here is joint A. I have 4 kilonewton to the left, and I don't know it's going up or down, so I'm gonna, if I assume P, since P over 2 is going up, I'm gonna say it's positive, minus 1.5 because it's going down, okay? And then I have 2 forces that are unknown. Of course, because this one is going up, I know that the arrow in AC, if I call that, oh, sorry, I don't know why I drew an arrow. The force AC should be compression, right? So that when you take the vertical component, they cancel each other. And if it's compression, meaning horizontal is pointing to the left and the 4 is pointing to the left, so forces AB should be tension pointing to the right. Here is my positive X and here is my positive Y. Of course, I will start with the Y because I have only FAC has a Y component. If I'm only working in the Y, it makes sense if you, when you become more like experienced, you would say, I have a triangle 3, 4, 5. The vertical force corresponds to the 3, and the inclined force corresponds to the 5. So the force in the inclined member is 5/3 the vertical one. It's that simple. You can do it right away. Otherwise, again, the slope here is 4, 3, 5. So you can see FAC times 5/3 equals P over 2 minus, so we can write it as summation of the forces in the Y equals 0. I have P over 2 minus 1/2 minus, because it's pointing down, 5/3 FAC. I'm sorry, 3/5 FAC, right? This is the 5, but I want the vertical component. I was trying to tell you that I could have just taken this force and multiplied by 5/3 to get FAC. Anyway, don't worry about it, equals 0. So 3/5 FAC when I move it to the other side, equals P over 2 minus 1.5. So FAC, you would multiply, as I told you, the P over 2 minus 1/2 times 5/3. See, you have a 3, 4, 5. The vertical is 3, so the incline must be 5/3 of the vertical. Anyway, so when you multiply that by 5/3, you will get 5p over 6. And when you multiply 3/2 by 5/3, you get 5/2. 5/2 kilonewton, right? And it's compression. Okay, and then you would say summation of the forces in the x equals 0. I have 4/5 of FAC, that's the horizontal component, and it's pointing to the left. So I would say 4/5 times 5p over 6 minus 5/2. That's negative because it's pointing to the left, minus 4 plus FAB equals 0. So FAB equals, when you keep it and move everything else, the 4, first of all, you have, this would be a positive sign, right? Because you're going to move it to the other side. So you would say FAB equals 4 plus 4/5 times that. So the 5 and the 5 cancel. 4 over 6 is 2/3. So you get 2/3 P. And then you get, again, notice we are going to move it to the other side. So that would be 4/5 times negative 5/2, which is negative 2, plus 4 is 2. So FAB equal this much kilonewton. And this one also is in kilonewton. Finally, since you already know these two, you can either, you only need one equation, either summation of the forces in the x equals 0 here, or summation of the forces in the y equals 0. So if I take summation of the forces, so joint B, summation of the forces in the y equals 0. Here is the joint. I already know FAB is is tension. So it's going out of the pin, and it's 2/3 P plus 2. And then I have the reaction going up. It's P over 2 plus 1.5. And then I have a compression force. Why compression? Because if the x is to the left here, x would be to the right there. If P is going up here, P is going down there. So this is FBC. And again, here is my x, here is my y. I can say P over 2 plus 1.5 minus, this is 3, again, 3, 4, 5, minus 3/5 of FBC equals 0. So instead, I'm going to say equals 3/5 FBC. Meaning I'm going to multiply both sides by 5/3. When you multiply by 5/3, you get FBC. Notice it's compression. So, but it equals 5P over 6. This is 3/2. So when you multiply it, you get plus 5/2 kilonewton. And this is compression. Okay, this one, FAC, is also compression. And this one is tension. FAB is tension. Okay, so now let's write that. The force for AB is 2/3, so 2 plus 2/3 P. The force for AC is compression, right? So we're going to write it as the opposite. So 5/2 minus 5P over 6. And this one is also compression. So I'm going to write it as negative 5/2 minus 5P over 6. Now, when you take the partial F by partial P, you get 2/3 here. You get negative 5/6 here and negative 5/6 there. After that, you have to cross out the P's. We are going to set P equals 0 because we said that was a fictitious force. So now I'm going to multiply F, which is 2, times L, divided by A, which is 400, and then multiply by 2/3. Let's see what we get. So we can simply use the calculator. We can say 8,000 times, so times that is F times L, times 2/3. I'm going to leave the 3 because instead of ending with a decimal, I'm going to divide by 3. And then I'm going to divide by 400. It tells me 80. So I get 80/3. Now, here, I get, that's a negative because negative times positive, 5,000 times 25/12 over 400. Negative 26/04. Well, if I multiply it by 6 by 4, it's 625 over, I multiply by 6 and 4, so over 24. When you get here, oh, they are the same numbers. So I will get plus 624/25. There is no reason to do it. We know the answer, right? And then when I sum, these two would cancel, and I will get 80/3. So finally, vertical deflection at C equals 80/3, and then you divide by G, which is 200. Remember that we said there is no reason to worry about the units. They cancel each other when these are in millimeters and it's in gigapascal. The reason being, gigapascal is giganewton per square meter, right? So to make it Newton, you would multiply by 10 to the 9th. But this would be square meter. A meter is 1/3, 10 to the negative third, 10 to the third of a millimeter. So I have to divide by 10 to the third square, which is 10 to the 6th. And that leaves me with 10 cubed. But then that's in kilonewton. So you would multiply it by 10 to the third to make it Newton. So they cancel with the bottom Newton. So you don't have to worry about multiplying and dividing because they cancel each other. And finally, you are going to divide 80 by 600, right? And you get 0.133 millimeters down. That's the deflection of point C in the truss using Castigliano's method. Of course, as I said, if they ask you also to find the horizontal deflection, I'm going to use this as P instead of 4. So you see here the force is 2, so it would be P over 2. 5 halves would be 5 over 8, 5P over 8, and that would be negative 5P over 8. So here you would, the derivative would be 1/2. This is P over 2. That would be 5/8, and that's negative 5/8. It seems like they cancel each other anyway, but there is nothing. At the end of the day, this would be in terms of P, because you are multiplying. This is P over 2 times 1/2 would be P over 4 times 8,000 would be 2,000 P. Divide by 400 would be 5P, but P is 4, so you write 20 kilonewton, just 20, and so on and so forth. There is nothing more you can do, and you will get the horizontal displacement very easily. I think you can do it on your own. That's so easy. If you have any questions about that, drop me a line in the comment section, and I will get back to you as soon as I can. I'll try to give you another one on how to deal with cases where I have a beam or a frame instead of a truss, since the truss is the easiest of the easiest structure. Thank you very much for your time. Hope to see you soon. Bye.